What we're going to do now is we're just going to add in new rules to memorize. There are only 4 of them, but they're ones that you really just got to know. First one, the derivative of sine of x is the cosine of x. Second one, the derivative of the cosine of x is not sine of x, but actually negative sine of x. Third one, the derivative of e to the x is itself. This is why e to the x is so completely and utterly awesome. It is its own derivative. It is the only function that is its own derivative. And then the natural log of x, and this is why we do so much with e and the natural log, is it has an interesting property that its derivative is 1 over x. Really wouldn't expect it looking at this, but this is going to come incredibly in handy actually in the next unit. Note that I do a cursive ln, otherwise it tends to turn into an I or just like get really weird looking, but that's natural log or ln. There's one thing that's going to be particularly helpful with remembering, especially these first 2 rules, and that is this little picture. The sine of x becomes the cosine of x. This is when we're taking the derivative. The cosine of x we saw becomes negative sine of x. Now, if you just think of this negative mean along for the ride, when we take the derivative of negative sine of x, it's going to go back to being cosine with a little negative in front. And same thing here, if there's a negative in front, then when we get negative sine of x for the derivative, we're going to multiply by -1, bringing us back in a full circle. So if you remember this, that's going to really help you out. What I want to do is I want to show you a little animation just of sort of like where that comes from and why this little cycle is. You don't have to take notes on this, I just want you to kind of see it. So this is a graph of sine of x right here. And what I'm going to do is I'm just going to put little points on for the derivative at each of these grid lines. So right here we can see that the slope is positive. It's in fact +1. So I'm just going to put a little dot there for that +1 derivative. Here we can see that the derivative is 0. The slope of the tangent line is 0. So put a dot there. At pi, the slope is -1. And at 3 pi over 2, the slope is back to being 0. So if I put those on and then connect them, lo and behold, what we have here is we have a cosine graph. The cyclical nature of the sine and cosine waves mean that when we take the derivative, we end up with another one of that type of graph. And if we start off with that cosine curve, and we do that same thing of just saying what's the derivative at each point, we see something else interesting. When x is 0, the slope of the tangent line or the derivative is 0. At pi over 2, that slope is -1. At pi, the slope is 0 again. At 3 pi over 2, that slope is 1. And when we connect those, we see a negative sine curve, just like we had right here. Finally, if we put in the points for the derivative of this negative sine graph, then we see a slope of -1, a slope of 0, a slope of 1, slope of 0, and up pops a negative cosine curve right there. And if we take the slope of that then what we see is right back where we started. When x is 0, slope is 0. When x is pi over 2, slope is 1. When x is pi, slope is 0. And when x is 3 pi over 2, slope is negative 1. And there we are. We're right back to our sine curve. So we're going to give a couple of examples of these and then check for understanding, and we're all done. So here are some examples. First, let's take the derivative of cosine x minus sine of x. And we're just applying our rules. Cosine of x, take the derivative, that becomes negative sine of x. Negative sine of x becomes cosine of x. It's not difficult. You just have to accurately remember your rules. So for example, this negative sine of x, right there, negative cosine of x, not positive cosine of x. Really, really easy to make that little mistake. Don't do that. The dragon will come and eat you. Rawr, rawr, rawr. Ah, no, 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 get away, don't attack, back, back. Bad me. Anyway. In a similar vein, let's say that we have the function f of x equals 2e to the x plus x to the fifth. If we want to find the derivative of that, this 2 is along for the ride, and then we have to remember this. The derivative of e to the x is just itself. This, however, this x to the fifth, this is what we were doing the other day. Here's where we bring down the 5, subtract 1 from the exponent to get that. We can also get these sort of all put together. We could take the derivative of 2 times the natural log of x plus 3 times the sine of x minus e to the x over 4. Let's look at that. Now remember, with our logarithm rules, we could turn this into 2 into natural log of x squared if we wanted. But because we do know what the derivative is of the natural log of x, there's no real reason to do that. If you did do it, there's a way to work with it, and you can make it work, but there's no reason to in this case. This 2 is just along for the ride. We saw earlier, natural log, the derivative of the natural log is 1 over x. Now here we've got the 3 along for the ride. We see that the sine of x, the derivative is the cosine of x. And here this might look a little weird at first, but think of this as being the same as negative 1/4 e to the x. So what it really is it's negative 1/4 derivative of e to the x is just e to the x. And there we go. So let's do a check for understanding problem, and then we're all done. If f of x equals negative 3 times the sine of x plus the natural log of x minus 2e to the x plus x to the 9th, find the derivative of f of x. Pause the video now. Okay, so that negative 3 is along for the ride. The derivative of sine is the cosine of x. The derivative of the natural log is 1 over x. Negative 2 is along for the ride. The derivative of e to the x is e to the x. And then this final one is using our power rule from yesterday. Bring down the exponent, subtract 1 from the exponent. Ta-da!